The ancient cratered highlands of the southern hemisphere of Mars has an intriguing and complex history, as it has been riddled with impact craters and modified by volcanic processes and by the wind. Additionally, it is one of the most heavily dissected terrains on Mars, exhibiting the densest population of valley networks. Old dried-up channels and valleys that may have been formed by surface runoff, the seepage of groundwater, or both. The Thermal Emission Imaging System aboard Mars Odyssey, in conjunction with spectral data from the Thermal Emission Spectrometer aboard the Mars Global Surveyor, have revealed the presence of a unique surface deposit that may be rich in chloride salts formed from the presence of liquid water. 3 separate missions have come to reveal the composition and nature of these unique deposits, which, although they occur as relatively small deposits, less than 25 square kilometers, are widely distributed in Noachian terrains with fewer occurrences in the Hesperian terrains. The salt deposits in this ancient, partially buried crater appears to be relatively thin and occurs in low-lying areas. It is also heavily pockmarked and discontinuous, possibly from removal of the material by erosion. Both of these aspects suggest that the deposit is indeed very old. The presence of such salts is intriguing and strongly suggests that conditions were favorable for water, near or at the surface in the geologic past. There are polygonal cracks on this and other deposits elsewhere on Mars which are similar to desiccation cracks, formed from the rapid evaporation and drying of a wet surface, and indicate that these were more likely deposited at the surface. However, the volume and duration the water required for these deposits is still being investigated. This terrain is located near the Mongala valleys on Mars. The Mongala valleys are a complex system of crisscrossing channels, located in the Tharsis region and in the Memnonia quadrangle. They originated in the Hesperian and Amazonian epochs and are thought to be an outflow channel system, carved by catastrophic floods and the release of vast quantities of water across the Martian surface. At the bottom of this view are two black spots that are recent impact craters. The black spots form because the craters exposed cleaner materials in the subsurface beneath the bright, dusty surface. This observation is also interesting because the surface has a crisscross pattern formed by wind activity. Bright ripples that are oriented from the upper right to the lower left are perpendicular to the wind flow. In contrast, outcrops that have been eroded by the wind are oriented perpendicular to the ripples to produce the crisscross pattern we now observe.